Hello, friends, colleagues, students, C# learners, and YouTube crowd. This is Dr. Satish Singhal, PhD. Uh, Here's the selection structure in C#, Part 3. Please watch Part 1 and 2. If you know this stuff already, then it doesn't matter. But if you are beginner in C# or beginner to programming, you will not get much out of this video unless you watch Part 1 and Part 2. So in part 1 we did basis of expressions, Boolean expressions, and relational and comparison operators. In part 2 we did logical operators and, or, and not, which combine only the Boolean values. In this one we are going to show you if structure and how that can be used to make a selection using the logical operator. And so basically professors use semester grade assignments, grading for the semester using this kind of table that if score is greater than or equal to 90, then grade is A. If score is in the range 90 to 80 or equal to 80, then grade is B. Ignore that for the time being. If score is less than 80 but equal to or greater than 70, then grade is C. If score is greater than, okay, if 70 is greater than score, that means score is less than 70 and score is equal to and greater than 60, then grade is D. If score is less than 60, grade is F. So we all know that. Schools and colleges use that. But one important point I want to make here is this is a valid Boolean expression because it will result to true or false depending upon what the value of score is. If the score is greater than 90 or equal to 90, this expression will be true, otherwise it will be false. And this one is also a Boolean expression. If the score is less than 60, it's true. If the score is greater than 60, it's false. But it is very important to understand these expressions do not indicate computer program the way computer programming is done. There are languages which will accept that, but result will not be what you think it should be. So let me be pretty blunt about it. This is not a computer program to do range selection for the score. It's a mathematical symbolic expression that tells you that score is confined in the range less than 90 or greater than or equal to 80. But if you write exactly the same thing in computer program, that's a complete and total disaster. Do not do this. Writing mathematical expressions exactly the way they are in computer programs sometimes is a complete horrifying disaster. So think before you do things like that. Okay? So this is not a computer program, and neither is these two. All right, so what will be a computer program version of this? Well, it will be this. Let me just make it a little better for you. Computer program version of this is really this. Uses the and operator. So if we write this way, computer can decide, will make two decisions. If score is less than 90, then this will be true. But at the same time, if score is greater than or equal to 80, then this will be true. So whole thing will be true. Remember and operator, true and true results in true, so then grade assigned will be B. So basically, if we choose only the integer values for this whole thing to be true, the score can have following value: 89, 88, 87, 86, 85, 84, 83, 82, 81, and 80. So this expression will be true for all those numbers. Okay, and then same thing we can say, this is the math, this is the computer program or computer science, this is math, this is computer science. Okay, so let's write a program based on that. We have done that already. Let me show you. And then we will run the program in compileonline.com. So C# has a static void main method. We declare a variable called score, set it to 0. We're going to use int. There are reasons not to use floating point here. That will be discussed much later. First, we prompt user to enter the final semester total, whole number only, from 0 to 100. And then we use the int.parse method, and whatever they enter, we read that using console.readline. So score has the numerical value anywhere from 0 to 100 they enter, and we set a variable grade as a blank character. So if score is greater than 90, we set the grade to A. If it's in the range of 89 to 80, we set the grade to B. Notice we are only using if structure, just one branch. If score is in the range 80 to actually 79 to 70, then we set the grade to C. If we score in the range of 69 to 60, we set the grade to D. Otherwise, we set the grade to F, and then we print the score and the grade. So let's go to compileonline.com and run this program. This exact same program is written here. There is no difference, although I see. Okay. Okay. I'll run it. So input I'll make here. Let's say score is 90. Compile and execute. So I'm surprised it's kind of okay. Actually, it will work. So enter semester score. I entered 90. 90 is inputted here. So grade is A. Well, let's change that to 85. Compile and execute. This time it takes 85. Grade is B. If I put 79, it should become C. C. If I put 65, it should be D. D. If I put 59, it should be F. And it is. So the program works, not a problem. This program works, but there is an efficiency problem in this program. Let me show you the efficiency problem. So I really want to make sure that it's in one page. For me to do that, well, that's fine. That's good enough. Notice there is an efficiency problem in this program because if the score is, let's say, 95, if the score equals to 95, then 95 greater than 90 is true. So I actually got the grade value right here. But still, computer is going to do this comparison. Of course, 90 greater than 95 is false, so this will not execute. But computer still will do this comparison, and 80 greater than 95 is false, so grade will not be reassigned. Okay. So it will not reassign the grade, but it will do this comparison. 70 greater than 95 is false, so no change in grade, and 95 greater than less than 60 is false too. So although grading is done here, computer does 1, 2, 3, 4 extra comparisons that are not needed. Okay. So in those situations, if most of students are getting A and B's, this program is slow. It slows down, and there are ways to make it faster. So one way to make it faster is just add the else in between. Else, else, else. And last one, you just need only else. You don't need the if. Else does not need a comparison. So all we need to do is just do else here. Okay, so why is this program faster? Well, that's the reason it's faster. If the score is 95, 95 greater than 90 is true, grade is A. Remember, between if and else, only either else is executed or if is executed. So if score is 95, if is done, grade is determined. Rest of the program falls under else block, so it's all of this will be skipped. Computer does not even bother to do extra comparisons after that. So if a lot of students get A, this program where we added the else block in between will be much faster, and it'll still work. It'll still work just the same. Okay, so let's do that in compileonline.com, and you can trust me that it'll work. Just put else here, else, else. And here I just need else only, don't need if. Else does not have a comparison condition. Don't make the mistake of putting else round braces and some condition. Else does not. Else is just an alternate. And also you can put them on the same line also. C# allows that. So if grade is now, let's say 95, okay, we got the grade A. 85, we got the grade B, okay, and so on. So program works just the same, but on an average, if most of the students are getting higher grades, A and B types, then this program will be faster. It will not be faster if everybody is getting an F. Then it's just as slow as the previous one. So that's, in general, that's one speed improvement. Now we want to show you the second speed improvement. Well, think about this, that if a score is 90 or higher, this will be true. Grade is set to A, and all that is skipped. Everything here is skipped up to here. Okay? So the logic is, and pay attention because this logic is easily lost. So logic is that the score is 90 or higher, this is executed, rest is skipped. So then why do I need to compare with 90? Because this statement is not reachable ever if a score is 90 or higher, which means this statement will be reached only if score is less than 90, because this will filter it out. For 90 or higher, this will filter it out. This is the filtering mechanism right here. So this is reachable only and only and only and only and only if score is less than 90. And if that's the case, why do I need to compare it? Because this comparison will be an extra slowdown of the computer. So in this situation, we can always delete this first condition. Okay, this is for my students. If I see this double comparison in nested if and else, Well, I'm going to deduct 10% points because this is just slowing down the computer for no reason at all. Okay? So this is the second speed improvement. Putting in else was first. Removing this double comparison is the second improvement. Okay? So we do that. And this compile online sometimes is a little funny. So I guess I have to put my cursor on S to delete all of these. That didn't work very well. Okay. Oh, problem. Let's delete the whole line. Okay. Okay. So this will work if I put 91 here. It failed. I think it's not liking this one. I don't know why. It's correct. Oh, over here. Yeah, I have an error over here. It's very hard to edit in this environment. Okay, it'll work now. Yeah, for 91 grade A, let's say 85 grade B, and so on. So if only one option should be there out of many, the nested if else, the way we have done it here, is the fastest. Okay. Now I don't want to give you an idea that just because nested if and else using the single comparison is fastest, that other options are never used. That's not my intention. There are computer programs where you have to use both standalone if and nested if and else. There's ice cream parlor example we will show that is like that. One part of the program uses nested if and else, other uses standalone ifs only. Both are used. There's not a control structure that is totally useless. But certainly in the case of when you are choosing, like grading example, when you are choosing one grade out of many, nested if and else in general could be the fastest most of the time. Okay. But standalone if and nested if and else are all used depending upon the kind of computer programming you do. Okay, so this is the use of logical operators and nested if and else. We'll do a part 4 where we'll show you graphical user interface version for a ice cream parlor store, and there we'll show that programs like that use both nested if and else as well as the standalone ifs. All right, thank you so much. This is Dr. Satish Singhal saying goodbye from part 3 of selection instruction C#.